This case study, demonstrating how data automation was used to reduce the time needed to collect, analyze and report quality control data from an optical fiber manufacturing facility, is brought to you by JMC Data Experts. Hundreds of spools of optical fiber are produced each day, with automated laser micrometers taking thousands of dimensional measurements for each spool. Quality control technicians spend endless hours analyzing and reporting the data, and not each technician carries out the task the same way. Automating these steps will not only save time, but also provide a process monitor and ensure the customer receives a standard capability report with each product shipment. Data automation uses programming language available in most statistical software to create macros to automate the collection, analysis and reporting of quality control data. This can save hundreds of hours of personnel time and provide real-time process monitoring graphics or control charts. For this optical fiber application, the first step was to use Open Database Connectivity, or ODBC, to import the dimensional data from their Microsoft Access database into Minitab statistical software. Executing the query manually one time will generate the programming code needed to integrate the data collection step in the global macro. About 10,000 rows of data for each spool are loaded into one spreadsheet, with each row containing a column for each of the raw dimensions: thickness, concentricity, diameter 1 and diameter 2. Each spool's data will typically contain 5 to 10% misreadings by the laser gauge. These are removed from the data using a subsetting command. Next, the raw data are converted to measurements that are meaningful to the customer. Finally, process capability, or PPK, is calculated for that spool for each of the 4 dimensions that are key to the customer: thickness, concentricity, average diameter, and overall diameter. The specifications for each particular fiber product code can be entered into the macro to execute the capability analysis for each of the 4 measurements for the spool. The spool identification code and the 4 PPK values are then exported to a summary worksheet. This summary dataset is used to provide a graphical overview of the product dimensions for the customer and used internally to monitor process performance. The requirements for the final graphical summary were 1 page. It should show the relationships between the 4 quality characteristics, and it must have the capacity for 30 to 50 spools commonly produced on one shift. The time series plot for 38 spools produced on one shift shown here indicate the best capability is seen for overall diameter and thickness, whereas average diameter and concentricity struggle to meet the internal specification of PPK equals 1.5 or higher. Roughly 500,000 rows of dimensional data are summarized on this single page. Since the spools are shown in chronological order, this plot can also be used internally to monitor the process. Implementation of the quality control program was easily achieved by creating a drop-down menu to execute the macro. This standardized the analysis by walking the technician through the macro steps. For this facility, data automation saved 43 days of technical time per year, provided a real-time process monitor to detecting potential bad product, eliminated operator errors by standardizing the analysis, and gave the customer a dimensional data summary to demonstrate process capability. Quality control data collection, analysis, and reporting can be automated for any manufacturing process. If you would like to use data automation to reduce your work time, or if you have any questions about this case study, contact us at JMC Data Experts.